Hey guys, it's Miss Nolan, and I just wanted to go ahead and do a quick review over speed and velocity. If you're watching this video, that means you should have already watched your two Edpuzzle videos, and I think those were a pretty good introduction to speed. But anytime there's math involved, I really like to work through a couple of example problems with you guys before you do your individual work. Make sure you guys really understand how to do these math problems. So we're going to work through some examples together. And I've also attached basically a copy of my notes right here. So those are attached on Google Classroom. If you have a printer, you may want to stop and pause this video and go ahead and print that off so that you can jot down what I'm writing down, and you'll have these notes later when you do your practice. And if you don't have a printer, then that's okay. You might just want to grab a sheet of paper and work along with us. So let's talk a little bit about what is speed. Well, speed is just a distance that's traveled over a period of time. For example, if we say a speed is 60 miles per hour, then what that really means is if you were to drive at an average speed of 60 miles per hour, it would take you exactly 1 hour to drive 60 miles. Or if you were to, let's say, throw a baseball 3 meters per second, every second that baseball is going to travel a distance of 3 meters. So there are really two things that you need to know to calculate speed. The two things are distance and time, and we're going to talk about that in just a second. Now, where does velocity come into play? Well, speed and velocity are basically the same thing, except velocity is speed plus a direction. That's really important, because if I'm asking you to solve for speed, then you do not need a direction. But if I'm asking you to solve for velocity, then you're going to have a direction there. So notice up here, a speed is 60 miles per hour. To turn that into a velocity, all we have to do is just add a direction. We add north, and now we have a velocity. 3 meters per second is a speed when we add just any kind of direction, like toward the door. If we add that direction right there, now it's not speed anymore, it's velocity. So how do we calculate speed and velocity? Since they are basically the same thing, except velocity also has a direction, and they have the exact same equation for solving those. So this is the way that it works. The equation for speed is distance over time. And some of you guys may be good at the algebra version. I'm going to show you, just remind you really quickly how we put that into a triangle. So speed, we're going to use the letter V to represent speed. Distance is going to be D, and time, we're going to use a T. So speed is distance divided by time. Now really quickly, remember the way we use this triangle is whatever you're looking to solve, you're going to cover that up. So if we're looking to solve for speed or velocity, that is distance over time. You guys see that? If we want to solve for time, that is distance divided by velocity or speed. And if we want to solve for density, these two are side by side. So I think I said density, I meant distance, guys. Distance equals velocity or speed times time, side by side, multiply. So there are some units that you guys will need to know. Speed is usually in meters per second, because distance is in meters. I know we don't use meters a lot here in the States, but it's used virtually everywhere else in the world because everybody else is on the metric system. So when we do science, we still have to use the metric system. So distance is going to be in meters, and time is going to be in seconds. And that's how we get meters over seconds for velocity, because distance divided by time, meters divided by seconds. So that's how we get that as the units for speed or velocity. So now that we have that, let's do an example problem together. So example number 1 says, if a car travels 300 meters in 30 seconds, what is its velocity? So since we're solving for velocity, then we know that velocity is going to be distance divided by time. And then we also have to remember, since it's velocity, we're going to need to add a direction to this. So don't forget to add your direction at the end. 300 meters. If we take a look at this, meters is always going to be distance, and then we have seconds here. Seconds is always going to be time. So now we just look at this and we plug it into our formula. So distance is going to go on top. So that's 300 meters divided by 30 seconds. And you guys can use your calculator on your phone or your computer or whatever. You may be able to do this in your head. 300 divided by 30 is going to be 10. And then you divide the units just like you divide the numbers, so meters per second. And you would also know that if you just remember up here, velocity and speed are always in meters per second. But don't forget to add that direction. So you can add any direction. Since it's not specifically mentioned in the problem, you can add north if you want to. This is a car, so I'll just say 10 meters per second down the highway. So it can be something just as general as that. If it doesn't give you a direction in there, like north or south, you can just add something like that or make up your own direction. Okay, example problem number 2. How long will it take for a ball to roll across the floor if that floor is 5 meters long, if it travels 1 meters per second? So it's asking how long it will take. So for this, it's actually asking us for time. How much time is it going to take? So let's go back up to our little triangle right here. Time is what we're wanting, so time is distance divided by velocity. So let's go ahead and set that up really quickly. Time equals distance divided by velocity. So this right here, 5 meters. Again, if we go back up here and look at our triangle, meters is always distance, so we can label that as distance. And 1 meter per second, that's going to be our velocity or speed. So we just have to say 5 meters divided by 1 meters per second. And take a look at these 2 meters right here. They cancel out. So 5 divided by 1 is 5. And then all we have left is seconds. And that makes sense because time is what we're looking for, and time is measured in seconds, as we have written up here on our triangle. Okay, the last question. How far does a football travel if it travels at a speed of 3 meters per second for 5 seconds? How far does it travel? So how far is basically asking us for distance. So if we're solving for distance, let's go up here to our triangle. Distance is a little different than the other two because it has speed and time, or velocity and time, side by side, so we're going to multiply those two. So distance is going to be velocity times time. And here, and remember this can also represent speed or velocity. So here we have a speed of 3 meters per second. Makes it easy for you because it goes ahead and tells you in the problem that it's speed. And then we have 5 seconds, so this right here is going to be time. And we're going to multiply these two together, and 3 times 5 equals 15. And if you notice, we have seconds here and seconds here. So these seconds are basically going to cancel out, and it leaves us with just meters. And that makes sense because we're solving for distance. And if you go up here to the triangle, our units for distance, we're always going to have meters on the end. So those are, and 3 example problems, 1 for velocity, 1 for time, and 1 for distance. I hope that that really helps you guys. And if you still have any further questions before you do your practice on Google Classroom, don't hesitate to shoot me an email or send me a message on Google Classroom. Thanks, guys.